In this video, we'll show you how to use the new enhanced MST emulation that was recently added to the quantumdata M42DE test platform. When testing an MST branch or hub device, the tester can operate like a reference MST source. You can connect a DP MultiStream device, and the tester will automatically discover and drive video to multiple sinks, really like a fully functional MST source. Also, in the latest release, the version 7.3.0 and later, you can now specify a primary and secondary format that can use different resolutions and patterns, and then direct that to a specific virtual channel in the network. Likewise, the M42DE also supports multi-stream capable branch device emulation. For testing a real MST source, the tester can present up to 16 virtual channels and 8 levels deep. So, that's going to address your most sophisticated MST test environments. If you have the source and sink emulation license on your M42DE, you can run this in loopback mode where the tester acts as both a reference source and reference sink. So this allows you to mimic a MST test environment to see the expected behaviors using a node-good test setup. It also makes it easier to see the tester emulate MST in real time. So let's take a look at how you can run this in loopback. Starting on the generator side, we have a typical standard format running here, 2160 at 60 Hertz. And of course, the M42DE as a generator has the ability to customize every aspect of the transmitted video stream, including the link rate, the timing, the patterns, the audio. On the far right, we click on the topology tab and we see it's blank, as the generator in UHBR mode always defaults to a single stream of DP video. Now we go over to the analyzer side. We see it's receiving valid video, 2160, 10 gigabit lane rate, all 4 lanes. Now, if you're testing a source for MST, you need to come in here and start by configuring the analyzer to emulate an MST topology. So we start that by going to the Tools MST button, and this is where the new functionality is. In this MST tab, it always defaults to the basic mode where you can define a simple one-layer MST topology with up to 4 sinks, just like with the previous release. But now we have the enhanced mode button that lets you graphically build the topology. By definition in MST, there's always a branch 0. We can start by using the Add Sync button. To add more sinks, just click it again. Now I have 4 sinks, but if I want to emulate an additional layer, I would click on the Add Branch button, highlight the branch, and then click again on the Add Sync, add that branch one more time. Now I have a total of 6 sinks with 2 of them located at this second layer. We've essentially told the test platform to emulate a multi-stream DP branch device. It's all virtual, just waiting for a source to connect, and then we'll respond to aux commands from the source with this exact config we see here, including the GUID and the relative addresses. You would then connect a source to the RX port. In loopback, everything's already connected. We simply issue a hot plug to start the topology discovery process, so the TX port is directly connected to the RX port in loopback mode on the tester. So now I go back to the generator. He's already completed discovery. He's sent the link address command, all the DPCD updates, and this is what the tester sees, shown graphically here. The green VC buttons at the top reflect the streams that are getting actively transmitted. And initially, it will just default to whatever active format we specified earlier. So 4VC at 2160 here. Now, the M42DE is limited to generating just 4 streams concurrently, but we now have the ability to select up to 2 different resolutions over MST. That is controlled with the pull downs at the top. You just pick the secondary format you want to use. It's limited to 720p 60, 1080p 60, or 21p 60. We set it for 1080p. You can also choose BPC and the individual pattern that you want to transmit. I'll choose the flat yellow pattern. Now you use this section labeled Video Override to tell the generator which VC gets the primary and which VC you want to send the secondary, which I can define by typing the number of the sync and S for secondary. I do that for VC2, VC3, and you can mix any combination of secondary and primary here, up to 4 total streams. Let's say you want to also send a secondary pattern to VC7, which is the second level sync here, and then I will tell the generator that I only want to send the primary format to VC8. So 8 and then a P sends the primary format to that sync identified as VC8. Then I'll use the Enable button, and that will immediately configure the transmitted streams. The generator, fully compliant with MST protocol, it'll calculate and complete the payload bandwidth table, based on the active link rate. It'll send the PBN to the branch device and perform all the aux transactions to configure the sinks. Now, if I quickly switch back to the analyzer, we see the secondary format on the first VC we selected. The tester puts the stream number 1 through 4 on the image, actually embeds it in the image before transmitting the pattern so you can easily identify which stream is active. This is the secondary yellow pattern, 1080p. We can go back to the Tools menu, MST tab, to switch to the real-time analyzer to see the other VC. So the stream number is not correlated with the sync number here, but clicking on the sync icon lets you quickly see that, yes, the override we set back in the generator is getting routed to the sinks according to their place in the topology using the relative address. We see 237. They are receiving the secondary pattern, and the sync number 8 is receiving the stream number 4, which is our primary format. So the primary can utilize all the enhanced DP features, DSC, FEC, every format. So that lets you cover a lot of your mixed mode test cases if you're doing an MST hub. Allows you to daisy chain 2 branch devices and still test mixed resolutions. But also on the analyzer side, you can access configuration details that were set by the source. The port statistics let you individually see the parameters for each port. It gives you the PBN value, what is used, what is available. That is all determined by the source and the format that he's driving. Looking at the VC table, we can see time slot allocation, 7 time slots used for each of the formats here, how the GPU is allocating these slots. Say you want to modify the DPCD values of these emulated sinks. Select the VC number, then use the read button. That opens the DPCD editor. Now you can modify the entries, shorten the aux read interval, see if the source can tolerate it, see when things break. You have full control here. You would need to write it back if you make any changes, or you can load a DPCD file from disk. You also have controls for setting the link training between the branch and the sink, so you can quickly constrain the bandwidth on an individual link. For example, I can select the sink number 3. I can select this second level branch device, go to the link training button. Here I can specify that he has a 4-lane link at HBR3, so the M42DE updates his DPCD registers, and after a hot plug you should see 8 gigabit link rate for this branch. Check the port statistics, make sure the source adjusts the PBN for that sync. Of course, you can save any of these topologies and then re-import it later with all the exact same parameters. Here's a typical test scenario. If you remove a sync from the topology, does the source detect it and make any adjustments to the bandwidth? You can select any sync, click Remove Device, click Disable and Enable, or Hot Plug. That should cause the GPU to re-enumerate the network. Because we're in loopback, we can go back to the generator and see that the M42DE behaves like a real MST source and updates the topology accordingly. So this gives you a complete emulation environment for testing MST, makes it easy to do ad hoc testing of your source driver. But another key enhancement in this release is the addition of over 100 turnkey conformance tests for MST source devices. We added the full set of tests here to QD Prime. A subset of these will eventually be promoted to the link layer CTS. It'll be up to the compliance working group to sort out which tests they want to keep, but you have this huge library that are available now. Again, caveat here, to run these today, you have to have a license for QD Prime Test Suite. We'll have a very similar set of branch and hub device tests soon as well. So get started now, get a jump on comprehensive testing for MST.